having seen the advantages during the compression stroke combustion, let us look at the disadvantages of the Comet design, in which there was a combustion chamber on top. More heat loss of air to the surrounding passage walls due to higher velocity of air. Higher velocity of air, the heat loss is to the passage walls. Hence, the lower temperature of air, instead of the heat loss, there is a lower temperature, cooler air, which will go to in the combustion chamber compared to other engines. This is a disadvantage. We want hot air. Also, the heat loss occurs when hot air is returning to the main cylinder. Hot air is returning from the combustion chamber to the main cylinder during expansion stroke. After compression comes the expansion stroke. So it is during that period. To overcome this drawback, a modification which provides insulation material to prevent heat loss. This is the pre-combustion chamber, this is the main cylinder. So to prevent the heat loss in this passage, an insulating material, as you see in cross, has been provided or surrounding the passage from between the combustion chamber and the main cylinder. Moreover, this heat absorbed by insulating material during the expansion stroke is given to the air during the compression stroke. Again, the next compression stroke, that heat which has been accumulated here will be provided in the next compression stroke. So this is a solution, some part solution. And so we get air which is hotter at the end of compression stroke. So the loss of heat has been addressed by providing this insulating material which absorbs the heat and uses it for the next compression stroke. Another modification is to provide a cavity on the piston. Now, this is the cylinder, this is the cavity, this is the pre-combustion chamber, hot gas is coming down, this is the side view, and this is the top view. You have air turbulence inside. This is the cavity of the inside, on top of the piston, the cavity. So let us see it, look at it. With this, some air is retained in the cavity. Some air is retained in this cavity. This air which is coming down is retained in this cavity. Less frictional loss in passage, as less air going to combustion chamber. Since some air is already in this, in the next cycle, you will have to have less air needs to come down. So combustion is in two stages. First stage was in the pre-combustion chamber. In the second stage, hot gases come down to the main cylinder. Second stage is in the main cylinder, first stage, second stage, and create a turbulence for better mixture. These hot gas is coming down, hot gases are coming down, they create turbulence due to their movement and create a better mixture. However, the combustion slows down, which is a disadvantage. Because of this long process, the combustion slows down, which is a disadvantage because of the reasons stated. Now we come to the third type of turbulence. The turbulence, having seen the first two, the third one is turbulence during the combustion itself. First was turbulence during suction, second was turbulence during compression, and the third was turbulence during combustion itself. Now, the initial part of combustion is used to create turbulence. This is the concept of turbulence during combustion. Initial part, combustion takes place, as you know, over this like period of time, the initial part, when it first, the mixture catches fire, and that is the time when we want turbulence. Use a pre-combustion chamber. This is a pre-combustion chamber, something like this. This was in the Comet. This is a pre-combustion chamber. This is the cylinder, and this is the piston. Simple diagram. Injector is in the pre-combustion chamber. This is found in Mahindra and Mahindra tractor engine. During compression, when the piston moves from BDC to TDC, air rushes to the pre-CC. Piston is moving up, the air will rush naturally to the pre-combustion chamber, part 3. Some will be retained here. Initial shock of combustion is in this combustion chamber, because the first stage of combustion we know it always takes place in the pre-combustion chamber. The first initial shock of combustion takes place here. Hot gases, part exhaust and part unburned fuel. Note this, hot gases, which comprises part exhaust, some is already burnt and some is yet to be burnt. Fuel passes through the passage to the main cylinder, where the second stage of combustion takes place. Whatever was left over, this unburned fuel, the combustion takes place in the second stage, above the piston in this area. These hot returning gases from top to bottom cause turbulence and so ensure proper mixing of diesel and air. This is the only part, most of it is unburnt. So this is the one which is coming down, creating turbulence and then burning off. So this coming down ensures, it's a turbulence, coming down, it's creating a turbulence, ensures proper mixing of diesel spray and air and proper combustion. Now let us have a look at some other pre-combustion chamber designs. It's called ASL. Now let me explain the figure first. This is the cylinder, this is the piston, and there is a projection above the cylinder. Injector is here, and there are 3 sections. Extension is called an air cell. We call this B. This is injector which sprays diesel. Let's call this part A. Let's call this part C. So injection pressure, when we inject pressure is adjusted to reach A. That means the pressure is adjusted such that it does not go, it finishes here A, where the first action takes place. So let us look at this pre-combustion chamber and let us look at the working. Since the diesel has been sprayed till A, naturally the combustion will also take place at A. So when combustion takes place, there is an explosion, pressure rise, temperature rise. So there will be pressure at this side, there will be pressure at this side. This side it compresses this air, and this side it moves towards B, where first diesel particles burn. The first diesel particles burn here. The hot gases are pushed towards B. First combustion, initial combustion, they are pushed towards B, and air in the C, and air which is there in C because of this explosion, this gets compressed and first air particles which burn are pushed towards B. Fine. And this air, once is pushed towards C, the air which is in C gets compressed. This is the first stage. First stage was the diesel is injected up to A and initial combustion started at A, creating pressure here, creating pressure this side. Second stage is combustion takes place at B, where there is proper mixing as diesel and air approach each other from opposite direction. The air is coming from here, the diesel is coming from here, and because this was compressed, so naturally there will be a force, back force. So the second combustion takes place here from opposite direction. There is a proper mixing, and this is the turbulence. This is the turbulence which we wanted, and the turbulence has also been created so to ensure proper mixing of diesel spray and air. This was the second stage. Let us see the third stage. Compressed gases in C, they have already started moving in the previous stage also, move towards B, and air above the piston, they move towards B. Some of it has already moved in second stage. A lot of compressed air towards B, and also to this area above the piston in the main head, cylinder head, to complete the combustion with leftover fuel. Whatever was left over moves here, and the combustion takes place in this area. So the combustion is over a period of time, or it's elongated. So what is the advantage of this? A longer combustion process which gives a very smooth engine running, which is desired. Because of the longer combustion process, the engine running is very, very smooth. However, the efficiency reduces, though proportionately very less. Efficiency reduces though, but proportionately it is almost negligible, but it's very less. So with this, we complete the combustion chamber designs of petrol and diesel engines, and also we complete the end of Unit 2. In the next lecture, we will study the first chapter or whatever is given in Unit 3. Thank you.